Okay, so let's look at the model. As we always want to do, we see a problem, and then we try to use a model to describe that problem. A model is a good thing in the perspective that we are going to describe the problem in details and precisely. Okay? Previously, let's say in a previous video, when I describe a problem in words, there are all kinds of possibilities. There are all kinds of different problems that fit my description. But after I give the model description, it's done. Okay, it can only be one problem. So let's see what's the problem precisely. Okay, as I mentioned in the previous video, this is a problem studying exclusive retail stores. Okay, so I don't care about those real retailers. There's no such option. I don't want to sell to retail options. I want to either sell my own product by running my company store or sell through franchise stores. Let's see what's happening here. One example about this kind of channel is gasoline. Okay? At least in the United States, many gasoline stores or gas stations are franchise stores. Okay? The company does not really own that gas station. It's some other guy running that gas station, and he has the power to, for example, set the price or to order the amount of oils stored in the station. Okay, so gasoline may be a franchise store, but as you may understand, there are also many gas stations that are company stores. Whether it is a company store or franchise store, for gas stations, they are exclusive retail stores. Okay, when you go to one brand of gas station, there is no other brand of gas for you to buy there. For automobiles, it's the same thing. Okay, I'm highlighting these are new automobiles. If you go to Toyota, then you may only buy Toyota there. There's no way for you to buy Honda or Ford. For fast food, it's the same thing. Okay, McDonald's, it may open many company stores owned by himself, or some independent guys may join the brand of McDonald's and open franchise stores. Okay, both exist in the world, but they are exclusive. You just cannot buy any Kentucky chickens in McDonald's, and so on and so on. Okay, so we are talking about exclusive retail stores. And then the paper want to search for conditions under which I can see the industrial equilibrium has 0 or 1 level of intermediary. Okay, here probably we should say 0 or 1. Okay, sometimes we're going to see 1 level of intermediary. Sometimes we're going to see no level of intermediary. Okay, here, how many levels is decided by the manufacturer. The manufacturer decides whether it is more profitable to sell through a franchise store or whether it is more profitable to sell through a company store. Okay, this is not fixed. It is chosen by the manufacturer. In this problem, there is a market. In the market, there are 2 manufacturers. Okay, these 2 manufacturers somehow corresponds to 2 firms or 2 brands. They are selling different but substitutable products, and that means if I want to buy this product, somewhat I can also buy the other product as a substitute. It is assumed that they are price setters, so they're going to set the prices for their products, and then the product demand will depend on both prices. Okay, if the other guy's price goes up, then my demand is also going to go up because my product becomes relatively more attractive. So if both of them choose no intermediary, or if both of them choose direct channels, then they are exactly playing a bird trend game or bird trend competition we mentioned to you in the previous lecture. And then suppose each of them choose to work with a retailer or a franchise store. Then in that case, they are having one level of intermediary. Then the manufacturer sets a wholesale price, and the retailer sets a retail price. And then the two players in the channel will play the channel pricing game, or the supply chain pricing game we mentioned in the previous lecture. So it's just that the manufacturer sets the wholesale price, and then the retailer sells the resale price, and then consumers see the two retail prices, and then demand realizes. Each of them is going to decide whether to downwards vertically integrate. What does that mean? Each of them knows there must be a retail store for its product, but each manufacturer needs to decide whether to downwards integrate that retail store. If I want to integrate, then I am running a direct channel. I am running my own company store. But if I don't do that, if I choose not to vertically integrate, then there will be a franchise store there. So, as we have two channels, in total we have three possible industry structures: pure integration, pure decentralization, or mixed. What are them? Suppose as a manufacturer, okay, manufacturer 1, manufacturer 2, if both of them want to reach customers directly, then this is called pure integration. Okay, they are just two integrated channels. Or if both manufacturers choose to delegate to a retailer, okay, and then retailers reach customers, then this is a pure decentralization channel, or we abbreviate it as DD, decentralization and decentralization. Again, don't forget, as a retailer, this is an exclusive retailer, so manufacturer 2 does not sell to retailer 1. Also, here, in this case, we are not actually saying that the manufacturers reaches consumers directly. There is still a store. Okay, there is still a store. It's just that the manufacturer controls the store. Finally, it's also possible that manufacturer 1 choose to reach customers directly, but manufacturer 2 choose to delegate to a retailer, right? In this case, we call it ID. Similarly, we may have DI if manufacturer 1 uses a retailer, but manufacturer 2 does indirect channel. So in total, we have 4 kinds of structures, but 2 of them are just an opposite to each other. So we can see that this is a dynamic game with embedded static games, or vice versa. We can also say this is a static games with embedded dynamic games. Okay, for example, here, suppose both of them choose to use DD, and then as manufacturer 1, I need to choose my wholesale price. Manufacturer then also choose his wholesale price. So at stage 1, these two guys play a static game, and then in stage 2, these two guys play another static game, and then everything will realize. So this is a particular situation where we say this is a dynamic game because there are 2 stages, but in each stage there are 2 guys making decisions together. Okay, so we are really looking at a combination of bird chain competition and the supply chain pricing. Okay, these are what's interesting here. We are combining the 2 basic models you learned in the previous lecture to become this one. Some more details. Suppose I am using ID, then you can see there will still be 2 stages, right? But in one stage there is only one decision maker, but in the other stage there are two decision makers. So there are many combinations of this game. So let's give you more details about the model. There are two manufacturers. Each manufacturer has a downstream retail store. Okay, the retail store is either a company store or a franchise store. Don't forget, this is what can be chosen by the manufacturer. The manufacturer can decide either this one or that one. And then the demand facing retail stores 1 and 2 are following this formula. Exactly what you have observed in a bird chain competition. Okay, so to make it simple, we say this is 1 minus P1 plus theta P2, with theta as a degree of substitutability. When theta goes up, that means these two products becomes more similar, and then my price is going to affect your demand more. When theta is very small, for example 0, then there is just no interaction between these two products. Okay, as we all know, it's reasonable for theta to be smaller than 1. Okay, because my price should affect my demand more than your price does. Okay, so that's a reasonable assumption. Finally, there is one thing I want to remind you. If you look at the paper actually starts with a more general model, and then the paper do some reductions and reformulations to show you that that more general model can actually be expressed like this. Okay, so this is not really simplifying too much. This allows us to ignore some tedious mathematical notations and derivations, but this is going to provide all the insights we need. If they are playing an II game, then this is just bird chain competition. So a manufacturer I sets retail price I by solving this particular problem. Okay, P is the price, Q is the demand. As we assume, I forgot to tell you, we assume there is no cost because it doesn't really matter. Okay, so the manufacturer 1's problem is going to solve P1 times Q1. Manufacturer 2, P2 times Q2. And then this is manufacturer's integrated profit. Okay, suppose they are playing DD, then in the first stage, manufacturer I is going to choose the wholesale price I to maximize the profit. Here, Q somewhat needs the manufacturer's prediction, because in the second stage, the retailer is going to set the retail price and to maximize the retailer's profit itself. Okay, under DD, the manufacturer cannot choose the retail price. The retailer will choose the retail price, and PI minus WI is the profit margin, QI is the demand. Again, QI is affected by PI and PJ. And then pi MI and pi RI are the profits of the manufacturer and the retailer under DD, or more precisely, the manufacturers and retailers' profits in channel I, if we are talking about pi MI and pi RI. Finally, it's possible for they to choose ID, right? So first, the manufacturer 2 is going to set the wholesale price W2. Okay? Because manufacturer 2 choose decentralization, so manufacturer must play the wholesale price decision first. And then the manufacturer 1 and the retailer 2 are going to set the retail prices by solving their problems to maximize their profits. If it's DI, then it's the opposite. Okay, so in any case, under any of the 4 market structure, we know what's the game sequence, and then go back to the very beginning. The two firms must think about what's going to happen in any of the 4 market structures. So they will choose D or I by themselves independently, and then it happens that one of the market structures will realize, and then they start to play the game, or more precisely, This is manufacturer 1, this is manufacturer 2. Manufacturer 1 can choose I or D, manufacturer 2 can choose I or D. If it happens that both of them choose here, then they play the II game in the sequel. Or if they choose here, then they play the DD game. Player 1 and player 2 plays this channel selection game at the very beginning. After that, they all observe their own and the other guy's channel structure, and then they play the pricing game. Okay, so that's the whole structure. As we all know, we need to use backward induction. So given any industry structure, we need to find their equilibrium prices and profits. That's what I will do in the next video. And then go back to the very first beginning. We can find the equilibrium industry structures. That's really what we want to do. It's about the industry structures or market structures. We want to ask, under this particular scenario, in this environment, is it possible for DD or ID or DI to be a Nash equilibrium? Okay, is it possible for them to choose to be decentralized directly and selfishly? Okay, we want to know whether a profit maximizing manufacturer will choose to do decentralization. Okay, so that's the model. Thank you.